Coral reefs are treasures of nature. The coral reefs and the ecosystems that they support are home to millions of species, many of which have surely not even been discovered yet. And there's an estimated about 500 million people living in the coastal areas in the tropical and subtropical regions of the planet that are directly depending on the ecosystem services that the coral reefs supply. You can think of seafood, simply food. Think of coastal protection. You can think of tourism and all the millions of jobs that are associated with that, just to mention a few examples. But there's a big problem. The problem is that the coral reefs are dying, and they're dying at an incredible rate. In the last 30 years alone, we lost about 50% of the world's global coral reef cover, and shockingly, I would like to say directly, in the where is the pointer here? Yeah. In the already in the midway through this century, which is not very far away in time, we are expected to have only about 10% of our coral reefs and their ecosystems functioning and alive. Why are they dying? They're dying for a variety of reasons. Some of them are local in nature, some of them are global in nature. Local environmental stress. It's no secret if you have too many people trampling on over the reefs and pouring stuff into the environment that doesn't belong there, eventually you will kill them. But a more subtle perhaps effect, global effect, but it's even more efficient in killing corals, is global warming. Because global warming translates into rising water temperatures, and rising water temperatures triggers this phenomenon we call coral bleaching. And coral bleaching is a stress condition that can kill the corals within a week or two. And this is how a bleached coral looks. It's white, bleaching. It's something, you bleach something, you turn it white. Why is it white? Well, it's white because at a certain, why does it bleach? It bleaches and turns white at a certain temperature. There's a certain temperature that it can sustain. We call it the bleaching threshold temperature. And above that, the coral reacts in a stress reaction, and it ejects from its tissue millions of little algae that live inside under normal circumstances. And those little algae symbionts, symbiotic cells, they are the ones that actually give the coral its color, because they contain pigments that color the corals. So when they leave, the coral tissue, the coral tissue itself is actually transparent, so you can see through the coral, and underneath the coral you can see the skeleton, which is white, calcium carbonate skeleton. That's why the coral turns white and bleaches. Now, turning white is not itself a big problem. Okay. The problem is that in this condition, the coral is dying. It is dying because it starves to death. It starves to death because these little algae here are actually providing, under normal circumstances, they're providing a very large fraction of the coral's diet, of its nutrients that it needs, if you want. Because these algae here, they can do photosynthesis. So they can take CO2 and turn it into sugar, and that sugar, they can give a large fraction of that sugar to the coral in a normal symbiotic functioning organism. And that provides the coral with a very large fraction of its diet. But when it bleaches and the algae leave, of course the coral no longer receives all this nutrition, and within a week or two it will starve to death. And this is happening on a massive scale around the world today. The Great Barrier Reef, the largest reef structure we have on the planet, it has a total combined surface area the size of Italy, has lost up to 30% of its coral reef cover, has been either bleached, is bleached, or is in a state of dying, or has died off in the last 5 years alone. Now you can think of Italy becoming uninhabitable, 30% of it, in 5 years. That would surely trigger a pretty big response, catastrophe response, action. But this is actually what is happening under the water in most parts of the world today. But there is one exception. There's one hope for coral reefs, and it's in the Red Sea. Because recently we have discovered, in collaboration with a number of people, including a number of people in the region, that the corals in the Red Sea are extremely resistant to global warming. In other words, at the end of this century, or even before, the coral reefs, especially in the northern part of the Red Sea and the Gulf of Aqaba up here, are probably going to be the last reef standing, the last coral reef ecosystem which is actually functioning and healthy. And that, of course, is an enormous opportunity. Okay. Because, of course, and that is conditioned on that this coral reef, which is, we found, is resistant to global warming, that it is protected, of course, and shielded against local environmental stress, local pollution, etc. So the protection of this coral reef, which is really a unique thing, and especially as we move forward and all the other reefs are dying, becomes more and more unique every day. The protection of this reef is, of course, a regional challenge. There's no particular country here which is responsible and the other ones not. Everybody in this region will have to work together to protect environmentally these corals. And this is why we have at EPFL taken the initiative as a neutral partner, because this region is not exactly known for... okay? As a neutral partner, to organize work to unite the scientists in the region in a scientific collaboration, which, as a first strategic goal, would be to establish the ecosystem baseline for this coral. Whoops. Because we need to know, and we know very little about this coral at the moment. It's actually an understudied natural phenomenon. We need to understand what is there and what state is in and what is the level of biodiversity, because only when we know this ecosystem baseline can we judge change in the future. And the center will work to establish that, and it will work to assess the environmental impact of several socioeconomic developments along the shores of the Red Sea, of which there's many in progress, and some of them are very big and massive and can potentially have a gigantic impact on the region, and use these collaborations and this scientific work to inform policy and lawmakers and provide them with the cutting-edge scientific assessments that they need for their decision-making to try to protect this. And of course, in this process, be an example of science for diplomacy and diplomacy for science in a region which is not easy to work with. Let me just put it like that. This project has the very strong backing of the Swiss Foreign Ministry. In fact, our Transnational Red Sea Center was kicked off 3 weeks ago by our Foreign Minister, Ignacio Cassis. And we are in the process now of establishing this center. We're in the process of fundraising. Any assistance is welcome. But we are basically, to sum it up, we are creating this transnational Red Sea Center because we must. We must work together at all levels to try to protect the coral reef, the unique and very large and biodiverse coral reef in the Red Sea. It's going to be the last reef standing, and it's going to be very, very important, not just to the countries in the region that are lucky enough to host this coral on their shores, but in fact to humanity as we move forward into the 21st century. Because this is the last hope we have for preserving large-scale coral reef ecosystems on this planet. Thank you very much for your attention.